Okay, we have a sinusoidal function given. So what I always start with when I do these problems is finding the maximum and the minimum. So the maximum, this pen is just not working, is equal to 5. The minimum equals 1. So we're going to find A, which is max minus min divided by 2. 4 divided by 2 is equal to 2. B, to find B, you need 2 pi over the period. And this does a full revolution in 2 pi. So the period is 2 pi. So 2 pi divided by 2 pi is going to give you a B value of 1. C, the x value where and here's your D, which is halfway between the max and the min. Let's do that for D first. D is max plus min divided by 2, which is going to be 3. And C is, we know we have a sine function here because that sine function is starting at the central axis, going to the max, central axis to the minimum, and back to the central axis. So I know this is positive sine. And that function period is going to start at an x value of 0, so that makes C 0. So this function is going to be y equals a, which is 2, times the sine of 1x. There's no minus c, or minus 0, plus 3. And that's that. Question number 31a. Question 32. Again, this problem's not too bad because, again, your maximum is 3. Minimum is negative 3. So A is going to be max minus min divided by 2, which is 6 divided by 2, which is 3. B is 2 pi over the period. And again, this period is going to do one full revolution in 4 radians. So period is 4. So this is going to be 2 pi over 4, which simplifies to give you pi over 2 for B. C, this, again, I'm choosing to do the sine function because it's the easiest one to do here. So this is sine. And that sine function begins at the central axis. Again, your central axis is here. And again, that's max plus min divided by 2, which is at 0. That shouldn't be not equals, that's just equal to 0. So D is equal to 0 here. And again, this is your sine function. And that sine function begins its period at an x value of 0. Again, so this can be written as y equals 3 sine of pi over 2 x, and then it's minus 0, so we just drop it, plus 0. This can be done as a cosine function, but this is, to me, the easiest way of doing the problem. Letter C. Again, grab your max at 2. Steal your minimum at negative 6. And again, A. It's going to be max minus min divided by 2. So A is going to be equal to 4. Your central axis is max plus min divided by 2. So it's negative 4 divided by 2, which is negative 2. So this here is your central axis, D. And that is at negative 2. So what appears to be the easiest way of doing this problem is I'm going to go between these 2 points here and do this cosine function. I'm starting at the maximum, so A is going to be positive. This starts at a C value of pi over 6. And half a period goes between pi and 7 pi over 6. So the difference between pi and 7 pi over 6 is 6 pi. 7 pi over 6 minus 1 pi over 6 is 6 pi over 6, or pi. That's a half a period. So the full period is going to be 2 pi. So b is going to be, whoops, where are you going over there? B is going to be equal to 2 pi over 2 pi, which is a period, which is 1. And again, we are using the positive cosine function here. So this should be y equals 4, because that's a, times the cosine of 1x minus pi over 6 minus 2. Question 32. Determine the equation that best describes a sine curve. So we know we have a sine. Amplitude is 3. So with amplitude of 3, a is either going to equal 3 or negative 3. So it didn't indicate one or the other. I'm just going to make it positive 3. If the period equals 6, we know b is going to be equal to 2 pi over 6, which is pi over 3. Gives you a phase shift of pi over 2 to the right. So c is going to be equal to positive pi over 2. It doesn't mention a vertical shift, so assume it's 0. So assume d is equal to 0. So therefore, our equation is going to be y equals either positive 3 or negative 3 sine of pi over 3 times x minus the phase shift of pi over 2 plus 0. You could leave it like that.